All right, guys, so what we're doing today and what we're kind of continuing on with is really just setting us up for solving. Setting us up for ways to solve these higher degree polynomial functions. And that's what the whole goal is. With division, it's giving us ways to reduce the degree of the polynomial by 1 or 2, bring it down to something we can solve. Because at this point here, we can solve quadratics. Bless you. Because if I have a polynomial as a quadratic in this form here, I can solve it using the quadratic formula. Because if I need to solve a quadratic for when this equals 0, I can use the quadratic formula and it would give me the answer. And that's what our main goal is. For any higher degree polynomial function, if I can bring it down to a quadratic, bring it from whatever its degree is down to a degree 2, then we can use the quadratic formula and solve. Now, we'll get other methods for solving, but that's kind of the main goal. If I don't have any other method, if I can bring it down to a degree 2, then I can solve from there. So if I don't have a way to solve it directly, I'll try to get it down to a degree 2 and then solve. Now, one of the other methods that we can do this with is factoring. So we're going back to factoring. Because if I can factor it, get it as a set of parentheses, squared, or more than one thing multiplied together equals 0, one of them has to be 0. Our zero product property is what we'll be doing. Now, we won't be solving anything today or tomorrow with factoring. We'll be doing a lot of just factoring it down, simplifying it. Actually, I take that back. We'll do some solving tomorrow, but today we're mainly focusing on factoring these higher degree polynomial functions. Today we're mainly focused on factoring. Now, what we're going to look at first, these here, is essentially the same thing we've done before, just with higher degrees. Because at this point here, we've only factored quadratics, degree 2. We've only factored things with a degree of 2, where the highest exponent is 2. But our steps still work the same, because our first main step is to find the greatest common factor. So when I look at A, looking at this here, x cubed minus 4x squared minus 5x, is there a greatest common factor between all three terms? And our greatest common factor would be x. Because x cubed, x squared, and x, there is an x in common with all three terms, yes? Now, up to this point, we haven't had variables as a greatest common factor, but we can factor out a variable. So if I factor this variable out, I'm pulling this term out. Well, if I factor x out of x cubed, I'm left with x to the what? Second. Minus 4x minus 5. We're pulling one of the x terms out of each of these here. So what is left? What is the degree of what's inside? It's a degree 2 now, yes? So now we can go back to our factoring methods that we did for quadratics that we did in this last chapter. So there's no greatest common factor left, so I have 2 sets of parentheses with 3 spaces. Then we look at the signs of the constant term, or the third term. So we're looking at the sign of negative 5. Well, the sign is negative, and if the sign is negative, the signs are opposites. Now we look at the factors of the first and third term. The factors of the first term, x squared, well, that would be just what? And x. The factors of 5, 1 and 5. And again, with any of these here, we're going to check them. So we do x times negative 5 and 1 times x. Well, x times negative 5 is negative. 1 times x is plus x. Negative 5x plus x is negative. Is that what we wanted? So we have it factored completely. And when we have it factored completely, because they're really going to focus on completely, especially with the assignment, if there is a power greater than 1, if a variable has an exponent greater than 1, we need to see will it factor. We need to make sure it will factor. If it does, we factor it. If it won't, we leave it alone. There cannot be any greatest common factors. There cannot be any common factors between anything inside the parentheses. If there is, we have to factor it out. It has to be as simplified as we can get it. Any questions on this first one here? Any questions on this first problem? Okay, let's look at the next one. So again, before we tackle any of these, you really need to see, is there a greatest common factor? Greatest common factor is going to make factoring these easier to do. Because 3 is a greatest common factor between 3 and 48. They do share that. 5y to the 5th and 5y to the 3rd. I can factor out y to the 3rd. I can simplify these. I can pull this term out of both. Well, 3 out of 3 would leave me with what? 1. If I pull 3 y's out of y to the 5th, I'm left with y to the squared. Because if I remove 3, how many do I have left? I have 2 left over. Minus. If I factor 3 out of 48, or 48 divided by 3 would give me 16. And that's it, because I've pulled all 3 y's out, because there were 3 there, and I removed 3, so there wouldn't be any left. Any questions on how we factored out 3y cubed, or why we factored out 3y cubed? Okay. Now, what's inside the parentheses has y squared, yes? Let's see if we can factor this. Well, we can factor y squared minus 16. It actually has a special name. It's what? A difference of perfect squares. Because y squared is a perfect square, yes? Y times y would give me y squared. Is 16 a perfect square? It would be what? 4 and 4. So y squared minus 16 is a difference of perfect squares. Now, because 16 is negative, we would have opposite signs. The factors of y would be y, and our 16 would be 4 and 4. And if we check it, y times negative 4 is negative 4y. 4 times y is plus 4y, which gives us 0 is what we wanted. This difference of perfect squares, if you can notice it, it makes factoring easier. Because again, if we have a difference of perfect squares, our general form was saying that if a squared minus b squared would be equal to a minus b times a plus b, where a and b are just the number that is squared, whatever we're squaring. Any questions on these first two here? Any questions on these first two problems? Okay. Let's look at this next one here. So looking at this one here, 5z to the 4th plus 30z cubed plus 45z squared. Is there a greatest common factor? 5 will go into all 3, and z squared will go into all 3. 5z squared, because 5 will divide into all 3 numbers, and z squared will divide into all 3 of these variables. Well, 5z to the 4th, well, 5 out of 5 leaves me with 1, because it simplifies out. Now, when I pull 2 z's out of z to the 4th, I'm left with z squared plus 30 divided by 5 is z, because z cubed divided by z squared, or pulling 2 z's out of z cubed, will leave us with z plus 45 divided by 5 would be 9. and z squared divided by z squared, or if we pull two z's out of z squared, it simplifies out. It wouldn't be a difference between perfect squares, but it would be a perfect square trinomial. But this here will factor. So we need to write it as two sets of parentheses. Now looking at this here, the constant, because, okay, so it'll factor, so we have our two sets of parentheses. Again, just like with factoring, we'll look at the constant term, and since the constant term is positive, these signs are the same, and they match the sign of the middle term, which is also. So our two signs would be positive and positive. After that, we look at the factors of the first and third term. So z squared and 9. Well, the factors of z squared would be and z, because there's only one set of factors for z squared. There's only one set of things that multiply together to give me z squared. Well, we have 1 and 9 and 3 and 3, but most likely we're going to use 3 and 3. And if we check it, z times 3 is 3z. 3 times z is plus 3z, which gives us 6z. Is that what we wanted? So that is factored. That is factored. Any questions on this here? Any questions on anything we've done so far? So this here is a lot of what we did when we factored in the last chapter, yes? Just the only difference is now we have a greatest common factor of something other than a number. We're also factoring out a variable. Questions on this here? Any questions on anything we've done so far? Okay. Let's look at this next one here. X cubed plus 10x squared plus 24. Is there a greatest common factor between all three terms? X. Yes, there's an x term in all three. So we can factor it out. I can pull it out of all three terms. Well, if I pull 1x out of x to the third, I'm left with x to the second. If I pull 1x out of 10x squared, I'm left with 10x. And if I pull 1x out of 24x, I'm left with 24. Questions on this here? Any questions on any of this here so far? Okay, now we need to see, will this factor? And this will. 10x, we're going to try to factor it. X squared plus 10x plus 24. Now, since 24 is positive, the signs are the same, and they match the sign of the middle term. So it'd be positive and positive. Now we need to find the factors of x squared. Well, the factors of x squared, well, we only have one set. It's just x and x. Now, 24 has a few. We have 1 and 24. 2 and 12. 3 and 8. 4 and 6, and we're done. How do I know it to stop at 4 and 6? Well, does 5 work? No. So I'm just increasing the number on the left. So I'm going 1, 2, 3, 4, 5 doesn't work. What's the number after 5? Would 6 work? Yes. Is it already listed? I'm done. Because once these two sides of the factors meet or cross, because they would cross at this point, yes? Because now I'm going back up, I'm done. Because once the two sides meet and I get numbers that are pretty much right next to each other, I'm done. There's no more factors. Because the other factors, if I kept going, would have been listed up this side. Does that make sense? So it's one way to kind of make sure you've got them all. Now, looking at these here, which one do we want to try first? 4 and 6. X times 6 would be 6x. 4 times x would be 4x, which gives us 10x, that's what we wanted. Bless you. Any questions on these here? How do we feel with these here with factoring these?
Confident.
We feel good with these here? Yes? Feeling more comfortable with factoring the more that we do? Awesome. Let's do 2 more of these. I want to do 2 more of these for sure. So looking at this first one here, 5y to the 6th minus 125y to the 4th. Is there a greatest common factor between these two here? 5y to the 4th, because there's at least 4 y's between both of them, yes? Both of them have at least 4. And 5 will go into both 5 and 125. Well, 5 divided by 5 will give me 1. I have 6 y's, or y to the 6th divided by y to the 4th is how we would technically do this. Or if I pull 4 out of 6, I'm left with how many? Y squared. Let's see here. It would be 25. And y to the 4th out of y to the 4th, well, that just leaves us with 25, yes? Is y squared minus 25 something special? Is it a special type? Yeah, this is a what? A difference of perfect squares, because y squared is a perfect square. It's y times y. Is there a number that times itself that gives me 25? 5, yes? So this is a difference of perfect squares. Now even look at this here, since 25 is negative, the signs are opposite. The factors of y squared, well, that just leaves us with y and y. And 5 and 5. Now always kind of, if I would just make sure to check it, y times negative 5 is negative 5y. 5 times y is plus 5y, which gives us 0. Is that what we wanted? Yes? And make sure when you're checking it, you're not just putting stuff down. Make sure you're actually multiplying. Yes. Yes. Questions on this here? Now again, I said if there's a power greater than 1 inside the parentheses, we have to simplify it. Is the 5y to the 4th inside parentheses? Well, no, the 5y to the 4th is outside, yes? Is there any way I can simplify just 5y to the 4th? No, there's nothing to simplify. There's no way to factor it. That's as simplified as it gets, yes? It's just 5y to the 4th. Whenever we're looking at completely simplified, I'm looking at what's inside parentheses here. Because these here, both these parentheses, the degree is 1, yes? It can't go any further, so we're done. This is factored completely. Questions on this here? Let's do one more before we move on to the next type. So when I look at this here, is there a greatest common factor between 6z squared, negative 24z, and 24? There is one. It is 6. This time we don't have a variable. It's just 6. Because there's not a z in all 3 terms. Z squared z, no z. So the only thing I can do is divide 6 out of all 3. Since the constant term is positive, the signs are the same, and they match the sign of the middle term. And the middle term is negative. We'd have z and what would be the factors of 4 we'd want to use? I would use 2 and 2. 1 and 4 would give us a bigger number. Because z times negative 2 is negative 2z. And negative 2 times z would be minus 2z, which would give us our negative 4z. 1 and 5, or 1 and 4, 1z, 4z would give us negative 5z. So it works out a lot of the times when we have this here, the signs are the same. Those factors are really being added together. combining them. Questions on this here? Any questions on any of this here? Okay. I want to move on to this here. Difference in sum of perfect cubes. The difference in sum of perfect cubes. So on your note sheets, let me get the highlighter. You need to write both of these down. You need to write both of these down. So you need to write both of these down. A cubed plus b cubed is equal to parentheses a plus b times a squared minus ab plus b squared. For the sum of perfect cubes. The difference of perfect cubes, a cubed minus b cubed equals a minus b in parentheses times a squared plus ab plus b squared. Do y'all have this copied down? Yes, okay. Now, we look at this here, there's going to be two main key things to these. These here are actually not that bad. They're actually kind of easy once you see the pattern. Whenever we solve these sum or difference of perfect cubes, and we see that they are, the first thing we do is we're going to take the cubed root of whatever the first term is and see what we get. And the cubed root of the second term. And if we get whole numbers, a and b, it's a sum of difference of perfect cubes. The first set of parentheses for a and b, we just plug them in. And in the second set, it's going to be a squared, a, no a. Y'all see that there on both of them? A squared, a's gone. It's going down to second power, first power gone. B is the same way, except it's going up. No b, b to the first b squared. And that's it. So let's look at this here. X cubed and 125, and it's a difference, it's a subtraction. So the first thing I want to see, is this a sum or difference of perfect cubes? So I'm going to take the cubed root of x cubed and the cubed root of 125. Now the cubed root of x to the third would be what? The cubed root of 125 would be what? What is the cubed root of 125? 5. Now for numbers for these here, you can type these in a calculator. Graphing calculator will be just fine. Because we're wanting a whole number. Because if it's not a whole number, it is not a sum or difference of perfect cubes. Well, we'd have to do it a different way. And at that point, I'd also check to see if there's a greatest common factor, because there might be. So this here is a difference because it's minus a perfect cube. Okay. Now we don't have two sets of parentheses with 3 spaces. I call this one a tractor trailer. Because the first one's going to have 3, and the second one's going to have 5. Right, now we're going to do the signs. Since it's a difference, since the sign is negative, the first one, they match. Opposite, always end on a positive note. Same, opposite, always end on a positive note. Okay. Let's plug in A. So our A term was the x. So it's going to be x squared, x, no x. squared first, well, 0, x to the 0, but any to the 0 power is 1, so we don't write it. Now let's look at b. Well, b is, so we'd have 5. Here we would not have a 5 because it's 5 to the 0. Then we'd have 5 to the first and 5 squared. Questions on this here? Well, now we need to simplify a little bit. Because x minus 5, that's as simplified as it gets. Over here, we would have x squared plus 5x plus 5 squared is 25. That's it. Now the question might be, because again, I said at the start of the lesson, if there's a power, if something inside the parentheses has a power or has a, exponent greater than 1, we're talking about the, Lord, it'll come back to me. Just because we have an x squared in this here does not, for this here, for perfect cubes, sum and difference of perfect cubes, will not factor. The quadratic part, or if the degree, there it is, if the degree of what's inside this parenthesis, I said at the beginning, is greater than 1, we need to make sure it factors, yes? It works out that the quadratic that comes out of these sum and difference of perfect cubes is not factorable. It is not factorable. This thing will never be factorable, no matter what we come across. So the quadratic that comes out of these sum and difference of perfect cubes will not be factorable. It will not be factorable. Questions on this here? We good with this here? Yes? So let's factor this one here. So we need to see, does x cubed and the square root of 64, are they perfect cubes? Well, the cube, or let me actually do the cubed root, not square root, cubed root. Well, the cubed root of x to the third is, the cubed root of 64 is,
I don't know how to do this cube root.
so this here, on the yellow calculators, will do cubed roots. You hit this, scroll over to where it says A and S, and type in 3. Now, on the graphing calculator, if you hit math, the math button, it should have 3, the cubed root down there. And yes, it would be 4. Yeah, so under math on the graphing calculator, number 4 on that list is cubed roots. That's 4. 4 times 4 is 16, and 16 times 4 would be 64. The signs, the same, so always end on a positive note. So our A, the one in the first spot is, so here we would have x squared, x by itself, and then no terms, no x's. Now 4 is our B term, so it would be 4. No 4 in with the x squared. X would have 4 to the first, and then we would have 4 to the second. Questions on how we got this here? So this would be x minus 4 times x squared plus 4x plus 16. Questions on any of this here? Questions on anything we've done so far?
I can tell if there's some, if they're the sum of two cubes.
Difference is what? Well, if we say I want the difference of 7 and 4, what would we do with 7 and 4? We would subtract. Difference is subtraction. Sum is add. Yes? So when we look at this here, these two numbers are being what? So it's the difference of two cubes. If they are perfect cubes, then it would be the difference of two cubes. If we're adding two perfect cubes together, it would be the sum. It's talking about what's in the middle. Questions over either one of these here? Let's look at this one here. Okay, so we want to see if it's the sum or difference of two cubes. Well, it'd be, if it is, it would be the sum because they're being added, yes? So let's cube root them. Can I take the cubed root of 16? Well, what number times itself 3 times would be 16? 4 times 4 is 16. Well, that doesn't work. 4, it's a decimal. Okay, so let's take a step back. Now, it says that this is part of sum and difference of perfect cubes, yes? So let's see. Is there a greatest common factor between 16 and 54? Well, there would be an s to the second, yes, because there's 2 s's in both at least. Is there a number that goes into 16 and 54 evenly? Does 2 go into 16 and 54? So if I factor this out, 16 divided by 2 would give me 8. S to the 5th divided by s squared, or 2 s's taken out, would leave me with s to the plus. 54 divided by 2 is 27. And s squared divided by s squared would be 1. So we get this here. Let's try again. Can I take the cubed root of 8? Is 2, yes? Because 2 times 2 is? Times 2 is? Mm-hmm. Now, the other one we need to look at is the cubed root of 27, which is 3. Because 3 times 3 is 9, and 9 times 3 is 27. So this here is now a sum of perfect cubes, yes? They had a greatest common factor we had to pull out. So again, on these here, check and see if there is one, because there might be. So when we look at this here is part of the answer. So the same, opposite, always end on a positive note. The same, opposite, always end on a positive note. Now, let's plug in our a's. So it would be 2s. Here it would be 2s squared, and then 2s by itself, and then nothing. Now, if we look at b, it would be 3, nothing, 3 to the first, and then 3 squared. Now, if up to this point you've been wondering so far, why do we write it in parentheses? Because 2s plus 3 doesn't change. Well, what would 2s squared be? It would be 4s squared. We have to square both terms. It would be 4s squared because we're squaring both. We're squaring both because it's 4s times 4s. Because we're multiplying it by itself. Not just the 2, but also the s. Now 2s times 3, 2 times 3 would be s plus 3 squared would be 9. And this whole thing would be the answer. Now if it's marking, well, you won't have an assignment tonight because we still have some more stuff to get through. But again, on these here, if you know you've done it right, 2 places I would check. 1, make sure the greatest common factor that you pulled out is still there. Make sure it's still written there from start to finish when you plug it in. Also, check the variable. Because again, big ideas math, if you put in x and it wanted s, it's going to mark it wrong. It wants the same variables as what it started with. On the test, I'm fine with you switching it up and putting x instead of s, but as long as they're all the same. Do not put s, 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 x. I will mark that wrong. You have to have the same variable all the way through. So